Today we're going to do our introduction to exponents. This is chapter 10.1. Remember like a chapter ago when I talked about how 2 to the thirds is not the same thing as 2 times 3? This number here tells you how many times a factor is being repeated. 2 to the third power can be rewritten as 2 times itself for a total of 3 times. 1, 2, 3. So we'll end up getting 8. We're going to zoom in a little bit. This here is called the base. It's telling you what is being repeatedly multiplied. Up here we have the exponent. Let's talk about our order of operations with exponents. When we're talking about PEMDAS, exponents always come before multiplication or division. In the case of these expressions, you are going to get different answers. Because you always do exponents first, this part, the part with the exponent and the base directly next to it, that is the part that gets finished first. Over here we see that the exponent is including the negative sign inside the parentheses. So let's do this first. This one is saying that whatever is inside these parentheses, which is being exponented, it's multiplied by itself twice. So we write out -3 times -3, and a negative times a negative is always a positive. Over here, the negative is not included inside of this expression. So another way to rewrite it would be to say this is the same thing as saying -1 times 3 squared. Because exponents are always done first, we square 3, we multiply 3 times 3, and we get 9, and it's being multiplied still by this -1, which means our result is going to be -9, where in this case it was positive. If there's a negative hanging out, make sure to check whether or not it's included in the parentheses, because whether or not it is will affect the answer you get. Let's move on to the product of powers. This basically says that if the exponents have the same base, so in our example here, the base is a in both cases, and if the exponents are being multiplied, which we see is happening because this is multiplying this, we check yes, they have the same base. That means you can add the exponents. If I were to have x squared times x to the third power, I see that they have the same base and they're being multiplied. So that means we can just rewrite the base and have x to the 2 plus 3, or x to the 5th. Let's look at this another way just to make sure you understand why this can happen. If I were to rewrite x squared as x times itself twice, and I were to rewrite x to the third as x times x times x, I would then count, okay, there's 5 x's, 1, 2, 3, 4, 5, and when I rewrite it in exponential form, I would get the same thing. So that's why that works. In an expression like this one, I have x to the 5th times y squared times y to the 1 power. In some cases, it's not even going to have any exponent because y to the 1 can just be written as y. We have to make sure we're only using the expressions that have the same base. X to the 5th does not share a base because x is different from x and y. It doesn't share a base with anyone. For y, we have 2 exponential expressions that have y. This one has an exponent of 2, this one has an exponent of 1. When we rewrite this, nothing can happen to the x, but you can combine the exponents of the y to say this is the same thing as y to the 2 plus 1, or y to the 3. So just a heads up, the same thing can work for negative exponents, which I'm not going to go into a lot of detail with right now, but just be aware that if I have the same base, so in this case the base is x again, and they're being multiplied, even though the exponent is negative, we can still combine these to say this is the same thing as x to the -2 plus 7, meaning that you'll get x to the 5th power.